Welcome back. We have been looking at types infinity minus infinity. We've already done one example. We'll do two more in this video, and then we'll move on to the next section. All right, let's try this one. This one has 1 over 10, which is cotan, but let's leave it as 1 over 10. Minus 1 over 4x. If you plug it in, you get 1 over 0 minus 1 over 0 plus, and so you get positive infinity minus positive infinity. Notice that it's important that I have 1 over 0 plus to make sure I have positive infinity. If I had 0 minus here, then this one would be minus infinity, and it would not be an indeterminate types because I'd have positive infinity, so a huge positive number, minus a huge negative number, that would still be positive. But here it looks like they could cancel, and so it's indeterminate. All right, so in this section, we're told that we could use different options to put them together. I could factor common terms, don't have any. I could put over a common denominator. So I'm going to do that. I don't have any logs either, so that's the only option I have. That's part of the reason I left it as 1 over 10. Otherwise, you'd have to work a tiny bit harder, and it'd be a harder problem if I wrote it as cotan here. So I'm going to do common denominator. I'm going to have 4x over tan of x. So 4x tan of x minus tan of x. All right, perfect. Now I have 0 minus 0 over 0 times 0. I have 0 over 0. I can use L'Hopital. I'm going to take the derivative of the top and the bottom. The top will not be so bad because it's a sum, and sum act nicely. So 4x is going to give me 4. They're easier to differentiate. And tan of x, the derivative, I'll give you 1 letter, 2 letters. Don't forget to square. Yep, secant squared. And then here I need a product rule. I'm going to get, well, 4x, that gives you 4, and then I'll leave tan of x, and then I'll leave 4x. So I have these two products. Tan is secant squared. All right, this is what I get. Let's plug in 0 into this. I get 4 minus secant of 0. I've done it a few times, but let me make sure that everybody can follow this. Secant of 0, secant is 1 over cos, so 1 over cos of 0, that's 1 over 1, it's just 1. So minus 1. 4 times 0, let's put 0 plus again, because I feel like the sign will be important. And then 4 times 0 plus, secant again is 1. All right, so I'm getting 3 over 0. And if you look at what's involved, everything is positive. I don't have a subtraction. I don't have a minus sign. So that 0 is positive. So I have 3 over something very small. That's going to be huge. And because both terms involved in the quotient are positive, the huge number will be positive 2. And so I get positive infinity. All right, but to argue this, you need to tell me that this is positive. All right, again, this is a bit of a challenge. All right, let's try one more. Let's say we have the limit tan of x minus secant of x as x goes to pi on 2. I don't have anything to factor. It doesn't look like I have fraction. I don't have log, so I'm a bit stumped. So one thing I could do, because they're trig functions, I know how to write them in terms of sine and cosine. So sine of x over cos of x minus 1 over cos of x. Because of that, it will be easy to join. So let me first plug it in. I mean, I'd rather plug it in here because I find it harder to know what secant of pi on 2 is. It's easier to do cosine, so that's why since I had to do it anyways, I might as well do it before evaluating. When I evaluate, I get sine of pi on 2 over cos of pi on 2. It's pi on 2 minus, so it's just before pi on 2. Actually, I'll need to graph it just to make sure everybody can see why what I'll do next is true. So if you look at cosine, it looks like this. So this is cos of x. I'm looking at pi on 2. Here's pi on 2, but I'm looking right before. So I'm somewhere here. So it's going to 0, but all the terms I'm looking at are positive. So what I'll get is sine of pi on 2, which is 1, and then 0 plus minus 1 over 0 plus. So I'm getting positive infinity minus positive infinity. All right, I need help because this is an indeterminate type. I'll put them over common denominator. That's not so hard here because they already have the same denominator. I will get sine of x minus 1 over cos of x. Now this is 0 over 0. I'm going to take the derivative of the top, that's cos of x. Derivative of the denominator, that's minus sine of x. And now if I plug it in, I'll get cosine of pi on 2, which is 0, minus sine of pi on 2, which is minus 1. So 0 over minus 1, 0. All right, so this is telling us that as x goes to pi on 2, tan of x and secant of x are both blowing up to infinity, and they're blowing up to infinity at exactly the same rate because their difference is getting to 0. I think it's nice. All right, so that's it for infinity minus infinity. In the next section, we'll be looking at powers. All right, so 1 to the infinity, 0 to the 0, and infinity to the 0. All right, see you then.